right? Which means that my vertical component, or my y component, because it's not technically vertical, but it's perpendicular to the surface, this component is now what? It's a right triangle, but it's, what trig function do I use in order to solve for it? The cosine. Because even though it's technically my y, because it's perpendicular to my surface, it's attached to my angle. Okay? So since it's attached to my angle, I have to use the cosine, because they are coworkers. So I'm going to call this the force of weight in the y direction.
With
Y. You may hear me refer to it as free weight. Okay? So the F, force of weight in the y direction, is equal to the cosine of theta, and it's a component of what?
force of weight.
Force of weight. Ecrom Ferris, are you okay back there?
So cosine of theta.
So cosine of theta times the force of weight. Okay, because it's a component to our force of weight. Yeah? Mm-hmm. Which means that my force of weight in the x direction is now going to be the sine.
Free wax.
Okay? Are we okay with this? We understand why we had to break it into components. Because when we're on an inclined plane, we lift it up, which means that my force of weight that's actually applying to the surface is now at an angle that's equivalent to the angle of the inclined plane. Okay? Alright, now the other forces we have, these are kind of right. The normal force is going to be perpendicular.
I meant to draw a line that way, but my view was like really off.
That's fine. Perpendicular to the surface. Yeah? So now, is it equal to my force of weight?
Free weight? No, it's
equal to free weight. So now my force, it's not equal to my force of weight, it's equal to my force of weight in the y direction. Okay? And then if it's at a constant velocity, then my frictional force is going to be equal to my the Fwicks. Yeah.
Fwicks?
Fwicks.
Like Fwicks, but Fwicks.
Yeah. Okay? It's still equal to the coefficient of friction times the normal force, too.
Do we have a name for FWX?
Fwicks.
Fwicks? Free wax.
Fwicks.
Fwicks.
Okay. We still, even though it's on an income plane, we still have force equals mass times acceleration, and we still have force applied minus force of friction.
G sine theta minus mu G cosine theta equals A.
Sure.
What?
Yo, back up real quick.
It's from the Super Saturday.
Back up real quick to
Okay.
the frictional force. So since frictional force is equal to Fwicks, does that mean that Fwicks is equal to mu times normal force? Okay, makes sense.
If and only if it's at a constant velocity.
Only at a constant velocity.
If and only if it's at a constant velocity.
And if it's not, then what do we do?
And if it's not, then you have to plug this in for this. It's the Fwicks,
It's that Fwicks.
because that's really what's pulling it down.